Hi, I'm Stuart from Fab Lab Maker Hub, and this is another in the pop-up Fab Lab series. Today I'm going to be doing a complete walkthrough from start to finish on designing an object in 3D and then printing it out on the 3D printer. I'm going to be using Tinkercad software and then using our Ultimaker 3D printer to print it out. Okay, let's get started. So here we are in Tinkercad. I'm just going to get rid of my pop-up Fab Lab logos. Okay, so today I'm going to design an egg cup. So I'm going to start off, the base of my egg cup is going to be a cone, and I'm going to need to make that bigger. I'm going to need to make that 40 by 40 by 30. And for the cup of my egg cup, I'm going to use a half sphere. And again, I need to make that bigger. I'm going to make that 50 by 50 by 30. Now that's the wrong way around. I need to turn it upside down, so I'm going to just rotate that 180 degrees. So what I need is to make a hole in the sphere there to make a cup. So what I can do is duplicate that and scale it down. I'm going to use the Control and Shift keys to scale down. So I'm going to scale it down to 45. So now I have a smaller half sphere kind of hidden inside that one. What I'm going to do is align them together. So align it to the top and to the middle of each side. Now I need to cut a hole in this. If I make this into a hole, but I'm not going to group them just yet. What I'm going to do is move them both up in the air so that they're sitting on top of my sphere. And let's see how, let's turn around to the side and see. I might need to move it down a little bit more, just make it a bit more of a squished egg cup. And again, what I want to do is align all of these together. So I want to align the bottom so that lines up. So that's nice and aligned. Okay, so what I want to do now is just group all of those together, and it will cut the hole out for my egg cup. And there we have a nice little egg cup design ready to go. So in Tinkercad, I'm going to export this as an STL file. STL files are the standard files that we use for 3D printing. So it downloads the STL file to my computer. So what I want to do now is convert it into a file that the 3D printer is going to understand. So this program here is called a slicer. Now I'm going to give you a practical demonstration of what a slicer does. So here I have an egg, and this is my favorite kitchen gadget, the egg slicer. So essentially what we're going to be doing is bringing our 3D model into this software. It's going to do to the 3D model what I'm going to do to this egg, which is essentially slice it up into small sections like that. And then the 3D printer will come along and build it up layer by layer by layer by layer until we have our complete model whole like that. So let's do some digital slicing with our slicing program. So I'm going to import my egg cup model. There it is. There's my egg cup model. The red indicates that there is too much of an overhang. So essentially what that means is it's going to be printing in kind of thin air. And obviously you can't print in thin air. There isn't too much of an overhang there, so it probably will turn out okay, but it might mean that we'll end up with a bit of a rough surface on this section. Now, if we wanted to, we could go back into Tinkercad and maybe sort of make that base a little bit wider, or just kind of like change the angle to compensate for that. But for the moment, I think I'm just going to leave it as it is. It should print out okay. Now over on the right hand side here, we have some settings. The main setting in terms of quality is what we call the layer height. At the moment, our layer height is set to 0.2 of a millimeter. So each layer in this model, just like on the layers of our egg here, have a certain width to them. The layers on our digital model will also have a width of 0.2 of a millimeter. Obviously, the finer the layer height, the greater the quality. So on the Ultimaker, we can go up to 0.05 of a millimeter and get a very fine layer height. The trade-off though is in terms of the time it takes to print. Something like that will print very slowly. So I'm going to go back to 0.2. The next thing is the thickness of the shell. 3D prints don't usually print completely solid, and equally they don't print completely hollow. You want to set what's called an infill, and between the infill and the wall thickness determines how strong your model will be. So at the moment our wall thickness is 0.8 of a millimeter. If we wanted it to be a kind of a stronger shell, we could change that to maybe 1 millimeter. Again, that will increase the time it takes. The next setting we need to look at is what's called the infill. As I was saying, you don't typically print models completely hollow or completely solid. So the infill lets you set a percentage. So 20% means that it's 20% filled with a grid pattern. The next thing we need to look at is how it's actually adhered to the plate. There is a couple of options here. We can print a brim, which basically prints a little flat surface for the model to stick to. The other option is we can print a raft, which is a big, thicker platform that the model sticks on. The other option is what's called a skirt, which essentially is just a perimeter around our model. Now to save time, I'm going to print a skirt. Once I have all these settings set, I'm going to hit the slice button, and it goes through and it works out how long it's going to take to print that model. It's telling us at the moment it's going to take 1 hour and 4 minutes to print our model. To speed it up, we could set a bigger layer height. If we go to 0.3 of a mil and slice it, we've seen it only takes 45 minutes. So if you're just prototyping something just to get an idea of how something looks, you can change the layer height there. The model won't look as such high quality, but you'll get a much better idea of what it looks like. We can also maybe change the infill as well, maybe to 10%. We'll slice that again. Now it's down to 39 minutes. Again, for a model like this, where we just want to get a quick rough prototype out, that's probably okay. I'm going to save this onto our little memory card here, eject it. One thing I want to do first though is just have a quick preview on the screen of how it's going to print it. So I can zoom in here and have a look at my model, and I can look at the layers. So I can see my 10% infill there, the crisscross pattern. That's okay for this type of model. And then as we come up, we can see the walls on the inside getting constructed. So now that we've got that, I can take my memory card, put the card in, turn the printer on, the printer warms up. First thing we're going to need to do is load some filament into the printer. I don't have any filament in there at the moment, so I have a roll of blue PLA filament here that I'm going to put in. So put it on the back. One thing I need to do is tell it that I need to change the material. So I hit material and change. And what happens is the hot end moves to the front there and it starts heating up the nozzle. We can't load the filament until the nozzle is up to the right temperature. Once that's heated up, what it'll do first is try and eject any filament that's in there. Well, there isn't at the moment, but it'll try to do that. And once it's done that, then we can load our filament in. I'll just turn the machine around so that you can see me loading the filament in. So that's the extruder on the back there. And there is a little kind of toothed gear inside the extruder that turns around. And there's a hole there for you to insert the material. So there you go. It's now up to the right temperature, and it's ejecting whatever material was in there before. Now I just have to go ready. Okay, so now I can insert our filament in here. I just wait till the kind of tooth gear grabs hold of it. That's good. As you can see, it's now coming up the Bowden tube here. This tube here is called a Bowden tube. Once it reaches the little mark there, we can hit the button on the front and get it to push it further up the tube. So there we go, it's now going all the way up the top. Okay, I'm going to turn that back round again so we can see what's happening. It's now pushing the filament down into the hot end, starting to melt the plastic, and we should see it starting to come out of the nozzle in a few seconds. There we go, and now we can see the blue filament coming out, so we can click OK, we're ready to go. So if we go back to our settings here, we just need to find the file that we had. There's our pop-up Fab Lab file. Hit go. So what's going to happen now, again, it's going to heat up the element inside the hot end and heat up the nozzle. The other thing it's also going to do is heat up the print bed too. So the print bed will heat up to around 60 degrees and the hot end will heat up to about 210 degrees. Once both of these are up to temperature, it will begin printing for us. So what's going to happen now is the print bed will raise up and it'll start extruding a little bit of kind of spare plastic. So there we go. So it's now going to extrude some plastic here, just to kind of prime the nozzle. And it's going to go over and then start printing our first layer. So it prints the skirt first, the skirt layer that we selected, and then it will start printing the first layer. Now it's important to just monitor the first layer to make sure that it's really sticking well, that we're getting nice even coverage of the plastic on the first layer. We're getting the nice first layer coming down there. The plastic is nice and evenly spread. There's no kind of holes or gaps in it. And you can hear the fans kicking in now. So your first layer is always printed with the fans turned off, and then the subsequent layers are printed with the fans turned on so that the plastic solidifies enough for the next layer to be printed. Okay, so that's going to take roughly, it says 50 minutes, but I'd say it'll print quicker than that. So we'll come back and see how it prints in the end. Well, that took roughly 40 minutes to print. The print is now finished. The bed's lowered down. The head has homed back to its position in the corner there. So that's quite cool to the touch. So now I should be able to just lift the print straight off the bed very easily, just like that. So there we go. There's our finished print. As I was saying, we get a little bit of what we call stringing here, which is where it was trying to print. Remember we saw on Cura that it was in red, which demonstrated that it was going to have a tough time printing those because there is too much of an overhang. And it is true, there is too much of an overhang, so we have a few sort of stray filament threads hanging down there. The actual overall egg cup is a good shape, nice and solid there. It feels quite sturdy to touch. So all that's left for me to do now is to test it out. I can grab my egg, put it in the cup, fits perfectly. So all I can say is have a cracking time 3D printing.